Have you ever lay awake in the profound silence of the night, feeling the comforting weight of gravity holding you safely to the earth, and wondered what invisible force is pulling the rest of the universe apart? We live our daily lives trusting in a world bound by unseen threads of attraction. You drop a smooth stone, and it gently falls to the ground. The moon, our quiet and ancient companion, orbits the Earth in a delicate cosmic ballet. The Earth, in turn, orbits the Sun, and our entire solar system sweeps majestically around the luminous heart of the Milky Way galaxy. Gravity is the familiar architect of our reality, the steady hand pulling matter together over billions of years to create the swirling galaxies, the burning stars, the wandering planets, and eventually the very atoms that make up your breathing body. It is a force that brings things together, forging connection in the vast, cold expanse of space. But when we cast our gaze outward, far beyond the familiar neighborhood of our own galaxy, into the deep, infinite ocean of the cosmos, we encounter a profound paradox that challenges the very foundation of our intuition. The universe, on its grandest scale, is not coming together. It is flying apart, and it is doing so with an ever-increasing urgency, stretching the fabric of space and time faster and faster with every passing moment. This is a mystery that invites our deepest wonder. Welcome, fellow traveler of the cosmos. I am Walter, the explorer, your guide on this quiet journey through the deepest and most profound mysteries of space and time. Before we drift further into the vast, uncharted unknown, I want to gently mention that 73% of the wonderful people who watch these quiet explorations have not yet subscribed to our channel. If you find peace, intellectual safety, and a sense of wonder in these cosmic journeys, please consider subscribing. It helps us immensely, allowing us to bring more of these meditative stories to you, and it ensures we can continue exploring the boundless universe together as a community of curious minds. Now, let us take a deep breath, leave the shores of Earth behind, and return to the dark, quiet expanse. Imagine, for a moment, the empty spaces between the stars. When you look up at the night sky, your eyes are naturally drawn to the light. You see the brilliant, ancient fires of distant suns, the soft, glowing clouds of stellar nurseries, and perhaps the faint, milky band of our own galaxy stretching across the darkness. But the light is just a tiny fraction of what is actually there. The overwhelming majority of the cosmos is made of the dark, the silent, the seemingly empty voids that stretch for millions and billions of light years between the islands of galaxies. For most of human history, we looked at this darkness and saw nothingness. We believed that the void was simply a stage, an empty theater where the grand play of matter and light was performed. But science, in its relentless and beautiful pursuit of truth, has revealed that this darkness is not empty at all. It is alive, it is active, and it holds the key to the ultimate destiny of everything that exists. The darkness is filled with a presence we cannot see, cannot touch, and cannot directly measure, yet its influence is so powerful that it dictates the motion of the entire universe. We call this enigmatic presence dark energy. To truly appreciate the mystery of dark energy, we must travel back in our minds to the early days of the 20th century. At that time, the greatest scientific minds, including Albert Einstein, believed the universe was static and eternal. It was a comforting thought, a vision of a cosmos that had always been and would always be, perfectly balanced and unchanging. But the universe has a way of shattering our assumptions with gentle, undeniable truths. In the 1920s, peering through the cold mountain air of California with what was then the largest telescope in the world, astronomer Edwin Hubble made a discovery that forever altered our place in the cosmos. He noticed that the fuzzy smudges of light in the deep sky were not just clouds of gas within our Milky Way, but entirely separate galaxies, island universes of stars in their own right. And more profoundly, he discovered that almost all of these distant galaxies were moving away from us. The light reaching his telescope was stretched, shifted toward the red end of the spectrum, a clear signature of retreat. The universe was not static, it was expanding. Space itself was stretching, carrying the galaxies along with it like leaves floating on a growing invisible river. This discovery was monumental, a paradigm shift that opened our minds to the concept of the Big Bang, a universe born in a single ancient moment of unimaginable heat and density, expanding outward over billions of years. But even with this profound revelation, our intuition still clung to the familiar mechanics of gravity. We assumed that, just as a ball thrown into the air must eventually slow down and fall back to Earth, the expansion of the universe must also be slowing down. After all, the cosmos is filled with matter. Trillions upon trillions of stars, massive black holes, sprawling clouds of gas, and vast halos of invisible dark matter. All of this mass exerts a relentless gravitational pull, a universal attraction trying to pull everything back together. It made perfect logical sense that this collective gravity would act as a cosmic brake, gradually slowing the outward rush of galaxies over the eons. We felt a sense of intellectual safety in this assumption, confident that the familiar laws of physics that govern a falling stone also governed the fate of the universe. But the cosmos is vast, and its capacity to surprise us is truly infinite. Fast forward to the year 1998. Two independent teams of astronomers set out to measure just how much the universe was slowing down. They did this by observing incredibly distant, ancient supernovae, exploding white dwarf stars that burn with a precise, predictable brightness, acting as cosmic lighthouses scattered across the deep void. By measuring the light from these dying stars, they could track the expansion history of the universe. What they found, however, sent a shock wave through the scientific community. The light from these supernovae was dimmer than expected, meaning they were farther away than they should be. The universe was not slowing down. The expansion of space was actually speeding up. Distant galaxies were moving away from us, and from each other, at an ever-accelerating pace. It was a profound plot twist in the story of our cosmos, a counterintuitive revelation that defied all expectations. Some unknown and unimaginably powerful force was pushing the universe apart, completely counteracting gravity and causing space itself to expand at an ever-increasing rate. We gave this mysterious force the name dark energy, but the name itself is an admission of our profound ignorance. It is a placeholder, a label for a shadow we cannot illuminate. It tells us what the force does. It is energetic, driving the expansion, and that it is dark, invisible, and imperceptible to our instruments. But it does not tell us what it actually is. What is truly humbling, what should fill us with a quiet sense of awe, is the sheer scale of this mystery. When we carefully measure the geometry and the expansion of the cosmos, we find that dark energy does not just exist in small pockets. It pervades every single inch of the universe. In fact, it is the dominant ingredient of reality. Modern cosmology tells us that all the ordinary matter in the universe, every star, every planet, every swirling cloud of stardust, every beautiful galaxy, and every human being who has ever looked up in wonder, makes up only about 5% of the total universe. Another 27% is dark matter, the invisible scaffolding that holds galaxies together. But the remaining 68% of the universe is dark energy. Let that sink into your mind for a moment. Nearly 70% of the cosmos is made of a mysterious force that acts as a kind of anti-gravity, pushing space apart rather than pulling it together. The vast majority of reality is hidden from us, a phantom presence dictating the ultimate fate of the stars. This realization fundamentally shifts our perspective. We are not the main characters in the story of the universe. We are a tiny, luminous afterthought, floating in an infinite ocean of dark energy. Yet, we should not feel insignificant. Instead, we should feel a profound sense of wonder that our minds, evolved on a small rocky planet orbiting an ordinary yellow star, possess the capacity to perceive this invisible ocean. We are the universe waking up, trying to understand its own vastness. The late, great astronomer Carl Sagan often reminded us that we are a way for the cosmos to know itself. And in our quest to understand dark energy, we are pushing the boundaries of that knowledge into the deepest, most quiet corners of reality. To search for the true nature of dark energy, we cannot simply build larger telescopes to peer further into the physical distance. The answer does not lie only in the macrocosm, in the majestic sweep of superclusters and cosmic voids. The answer, strangely and beautifully, might lie in the microcosm. To understand the largest scales of the cosmos, we must journey inward, down into the unimaginably tiny, frantic, and bizarre world of quantum physics. We must look closely at the very fabric of nothingness itself. In the gentle silence of our contemplations, we will find that empty space is not a void, but a bubbling, infinite sea of potential. It is here, in the paradox where the infinitely large meets the infinitely small, that our journey truly begins. We stand on the shore of a great mystery, looking out into the dark. We do not have all the answers, and that is perfectly all right. The joy is in the journey, in the slow, careful unraveling of the unknown. We are explorers, gently pushing against the boundaries of our own understanding, finding beauty in the very questions that challenge us. In the chapters to come, we will dive into the quantum realm, seeking the microscopic seeds of this cosmic acceleration. We will embrace the humility required to face a universe that is stranger, more vast, and more deeply mysterious than our ancestors could have ever dreamed. Let us drift further into the mystery together. Close your eyes for a moment and imagine the concept of true, absolute nothingness. What does emptiness actually look like to you? For most of our recorded history, human beings have conceptualized the vast vacuum of space as a grand, silent stage. We imagined it as a dark, passive container, an endless void where the magnificent, fiery drama of the cosmos simply unfolds. We tend to think that if we were to travel far beyond the glowing, swirling spiral arms of our Milky Way galaxy, past the distant, ancient halos of elliptical galaxies, and deep into the vast, quiet voids that separate the great superclusters, we would find a place of completely undisturbed nothingness. Imagine, if you will, taking a hypothetical box, a perfect cube, and placing it deep within one of these lonely cosmic voids. Now, Imagine meticulously emptying every single thing out of this box. First, you gently sweep away any stray, wandering atoms of hydrogen gas. Then, you reach in and remove the ghostly, invisible particles of dark matter that might be drifting through. Finally, you build the walls of this box out of a material so impossibly perfect that it blocks every single photon of starlight, every ancient microwave echo left over from the dawn of time, and every wave of radiation traversing the infinite universe. What are you left with inside that perfectly sealed, perfectly dark, perfectly empty box? Common sense, the comfortable intuition we have developed by living our entire lives on the dense material surface of the earth, tells us that the box must contain absolutely zero. Nothing at all. A perfect, silent void. But the universe is under no obligation to make sense to our everyday human intuition, as the brilliant astrophysicist Neil deGrasse Tyson often gently reminds us. When we ask modern science to look inside this hypothetical box of nothingness, the answer it gives us completely shatters our basic perception of reality, opening a door to a profound, breathtaking wonder. According to the strange, counterintuitive, and beautiful rules of quantum mechanics, true nothingness is a physical impossibility. The absolute silence we imagine does not exist anywhere in the vast cosmos. Instead of an empty, passive void, the vacuum of space is actually a boiling, dynamic ocean of infinite potential. To truly understand this, we must embark on a journey into the incredibly small, stepping away from the grand scales of galaxies and superclusters, and shrinking our perspective down to the subatomic realm. We must travel to a place so tiny that the very concepts of distance and time begin to lose their familiar, comforting meanings. In the 1920s, around the same time that astronomers were first realizing the universe was expanding, a group of brilliant, deeply curious minds were unlocking the secrets of the microscopic world. One of the foundational pillars they discovered is known as the Heisenberg uncertainty principle. Werner Heisenberg revealed a fundamental, inescapable limit to what we can know about the fabric of reality. He mathematically proved that you cannot simultaneously know both the exact, precise position and the exact, precise motion of a subatomic particle. The more tightly you focus on where a particle is located, the less you can possibly know about where it is going. But this principle of uncertainty extends far beyond just position and motion. It also beautifully and bizarrely applies to the relationship between energy and time. The uncertainty principle dictates that the exact energy of any given volume of space cannot be exactly zero for a precisely defined period of time. There is a built-in, inescapable jitteriness, a fundamental restlessness to the very fabric of the cosmos. Because of this fundamental quantum fuzziness, empty space is never, ever truly empty. It is constantly, endlessly vibrating with raw energy. From this underlying, invisible sea of energy, ghostly entities known as virtual particles are constantly popping into existence. Imagine them as tiny, fleeting sparks in the dark. A particle and its antimatter twin will spontaneously materialize out of the pure nothingness. Borrow a tiny amount of energy from the vacuum, exist for a fraction of a billionth of a second, and then collide, annihilating each other and returning their borrowed energy back to the void. This incredibly fast, invisible dance happens everywhere, all the time, in every single cubic centimeter of the universe. Right now, in the space between your eyes and the screen, in the microscopic empty spaces between the very atoms of your own body, And in the deepest, most remote, silent voids of intergalactic space, this frantic dance of creation and destruction is taking place. The quiet, ancient vacuum is actually a roaring, seething quantum foam. When we look up at the night sky and feel a sense of profound peace in the apparent stillness of the stars, we are actually looking through a stormy, boiling ocean of virtual particles. This is the magnificent paradox of our universe. The ultimate cosmic silence hides an infinite symphony of quantum activity. You might wonder, with healthy skepticism, if these virtual particles are just a clever mathematical trick, a theoretical concept written on chalkboards but possessing no physical reality. But science demands rigorous evidence, and the cosmos, in its gentle wisdom, provides it. In the year 1948, a Dutch physicist named Hendrik Casimir proposed a brilliant way to prove that the quantum vacuum is real and that it exerts a tangible physical force. Imagine taking two incredibly smooth, uncharged metallic plates and placing them facing each other in a perfect, artificially created vacuum. You bring them exceptionally close together, separated by a microscopic distance of perhaps 1/1,000,000th of a meter, a gap far thinner than a single strand of human hair. According to the laws of classical physics, because the plates have no electrical charge and the space between them is completely empty, absolutely nothing should happen. They should hang there in the silent dark, perfectly still. But Casimir calculated that the boiling ocean of virtual particles would change the situation entirely. Outside the closely spaced plates, virtual particles of all sizes and quantum wavelengths are constantly popping in and out of existence, bouncing against the outer surfaces of the metal. But in the incredibly tiny microscopic gap between the two plates, only virtual particles with specific, very small wavelengths can fit. The larger quantum waves simply cannot exist in that confined, restrictive space. Because there are more virtual particles constantly bombarding the outside of the plates than on the inside, there is a very real, measurable pressure pushing the plates together. Decades later, with the advancement of incredibly precise laboratory technology, scientists actually performed this delicate, difficult experiment. And exactly as Casimir had predicted, the plates were gently but firmly pushed together by the sheer force of nothingness. The vacuum of space has a tangible, physical weight. It is an active, living, breathing component of the cosmos. The implications of this discovery are so profound that they can induce a beautiful kind of intellectual vertigo. We have spent our entire lives thinking of space as a mere container, an empty box that simply holds the things that truly matter: the shining stars, the wandering planets, the majestic galaxies, and ourselves. But quantum physics tells us that space itself is a physical entity, a complex fabric woven from endless microscopic fluctuations of energy. It is not the empty stage, it is the main actor in the grand cosmic drama. And this profound realization brings us back to our great, overarching mystery: dark energy. If every cubic millimeter of empty space in the infinite universe contains this seething, bubbling quantum energy, then the vacuum itself must have a total, massive energy value. And as Albert Einstein famously taught us with his elegant equations of relativity, energy and mass are fundamentally the exact same thing, just different sides of the same cosmic coin. This means that the energy of the quantum vacuum exerts gravity. But here is the most counterintuitive, mind-bending part of our entire journey today. In the complex mathematics of Einstein's general relativity, the energy of the vacuum does not pull things together like the familiar gravity of a star or a planet. because the vacuum has a uniform, constant energy density, and because it exerts a bizarre kind of negative pressure, its gravitational effect is actually repulsive. Instead of pulling matter inward to create galaxies, the energy of empty space pushes space outward. It causes the very fabric of the cosmos to stretch and expand. Could this quantum vacuum energy, this endless boiling sea of virtual particles, be the true identity of the dark energy that is accelerating the expansion of our universe? It is an incredibly elegant, deeply poetic idea. The very emptiness of the cosmos, the vast, silent oceans of nothingness that surround the gentle islands of galaxies, is the driving force of the universe's ultimate destiny. The nothingness is pushing everything apart. When we contemplate this immense paradigm shift, we are invited to feel a profound sense of humility. We look out into the night sky, and we realize that the visible universe, the majestic tapestry of light and matter that we have studied and admired for millennia, is just a tiny, fragile foam riding on the surface of an infinite, invisible ocean of dark energy. Our everyday experience of reality, bound by the gentle pulling gravity of our home planet, is an exception, a rare and highly localized phenomenon in a cosmos governed by a completely different, unseen, repulsive force. This realization does not make us insignificant. Rather, it connects us to a mystery far greater than ourselves. It transforms our understanding of the universe from a static, mechanical clockwork into a dynamic, living entity, where even the empty spaces hold unimaginable power and ancient secrets. As we journey further into this mystery, we must hold on tightly to this sense of respectful wonder. We must learn to sit quietly with the unknown, finding a deep inner peace in the tension between what we can clearly see and what remains hidden in the vast dark. The universe is a grand, continuously unfolding poem, and we are just beginning to learn how to read its most subtle and beautiful verses. We are explorers standing on the shores of a vast quantum sea, looking out at an expanding, infinite horizon, fueled by an insatiable, gentle curiosity. As we continue to float together in the profound, comforting silence of our contemplation, let us carry the image of the quantum foam carefully in our minds. We have journeyed down into the very smallest conceivable scales of reality, leaving behind the familiar, comforting weight of everyday objects. And we have discovered that true emptiness is a physical impossibility. The vacuum of space, that quiet darkness that stretches between the ancient stars, is alive. It is a bubbling, restless ocean of infinite potential, where virtual particles endlessly pop into existence and vanish again in a fraction of a heartbeat. This continuous, microscopic dance of creation and destruction gives the very fabric of empty space a tangible, intrinsic energy. But how do we connect this microscopic, frenetic quantum storm to the majestic, accelerating expansion of the entire universe? How does the invisible energy of nothingness push apart the great superclusters of galaxies? To weave these two seemingly separate realms together, we must gently step back from the subatomic world and return our gaze to the grandest scales of space and time. We must revisit the elegant, beautiful mathematics of the greatest mind of the 20th century. Before we embark on this next profound step of our exploration, I want to take a brief, quiet moment to introduce myself properly. I am Walter, the Explorer, your dedicated companion on this ongoing cosmic journey. As we navigate the deep, beautiful mysteries of the universe together, I notice that 73% of the wonderful, curious souls who watch these videos and share in these contemplative moments have not yet subscribed to our channel. If you are finding a sense of peace, intellectual safety, and deep wonder in our shared explorations of the night sky, please consider gently pressing that subscribe button. It helps our small community immensely, allowing us to continue crafting these quiet stories and ensuring that we can keep looking up and wondering together for many journeys to come. Now, let us return to the dark, quiet expanse and the magnificent puzzles it holds. In the early years of the 20th century, Albert Einstein unveiled his general theory of relativity, a masterpiece of human thought that completely redefined our understanding of gravity. However, when Einstein applied his beautiful equations to the universe as a whole, he encountered a deeply unsettling problem. The mathematics insisted that a universe filled with massive, gravity-exerting objects could not simply sit still. It had to either be dynamically expanding outward or violently collapsing inward under its own collective weight. But the prevailing philosophical and scientific belief at the time, a comforting assumption shared by almost everyone including Einstein himself, was that the cosmos was eternal, static, and completely unchanging. To force his elegant equations to describe a still and quiet universe, Einstein introduced a new, arbitrary mathematical term into his work. He called it the cosmological constant. This constant represented a mysterious, pervasive anti-gravity force, a property of empty space itself that pushed outward with exactly the right amount of strength to perfectly balance the inward pull of all the matter in the universe. It was an intellectual fix designed to keep the cosmos frozen in eternal stillness. A little over a decade later, when Edwin Hubble peered through his telescope and definitively proved that the universe was actually expanding, Einstein realized that his static universe was an illusion. He famously removed the cosmological constant from his equations, reportedly calling it his biggest blunder. For decades, the cosmological constant was relegated to the dusty archives of scientific history. A curious historical footnote, a mistake made by a genius trying to preserve an obsolete worldview. But the universe, in its infinite and quiet wisdom, has a magnificent sense of irony. When astronomers at the end of the 20th century discovered that the expansion of the cosmos was not slowing down but actively accelerating, they needed a mathematical way to describe this mysterious dark energy. And what they found, waiting patiently in the shadows of physics, was Einstein's discarded blunder. The cosmological constant was resurrected, not to keep the universe perfectly still, but to explain why it is flying apart at an ever-increasing speed. It might be a property of empty space itself, something called the cosmological constant that Albert Einstein once proposed, and then called his biggest blunder. We now know that dark energy acts as a kind of anti-gravity, pushing space apart rather than pulling it together. It is an inherent, fundamental characteristic of the vacuum. As the universe gently expands and the ancient galaxies are carried further apart, the total amount of empty space increases. Because this energy is an intrinsic property of space itself, more space means more of this mysterious repulsive energy. This creates a breathtaking, accelerating feedback loop. The more the universe expands, the more dark energy exists to push it apart even faster. This invisible force has grown to dominate the cosmos, and we now know that it makes up about 68% of all the energy in the universe. This beautifully simple mathematical concept, a constant energy embedded in the very fabric of nothingness, seems to perfectly describe what astronomers observe when they measure the retreating light of distant supernovas. And here is where the profound poetic connection to the quantum world reveals itself. When cosmologists look for a physical explanation for what Einstein's cosmological constant actually is, they look directly at the bubbling, restless ocean of the quantum vacuum. The quiet tension of the vacuum could be the very thing driving the majestic expansion of the cosmos. It is a beautiful synthesis of the unimaginably small and the incomprehensibly large. But science is a journey of relentless questioning, a continuous path that never truly ends. Just as we feel we have grasped a profound truth, the universe presents us with a new, even more magnificent mystery. When theoretical physicists attempt to calculate exactly how much energy should be contained in the quantum vacuum, using our most rigorously tested theories of subatomic particles, they arrive at an answer that shatters our understanding completely. According to quantum mechanics, the energy of the boiling vacuum should be incredibly, overwhelmingly dense. It should be so powerful, so tremendously strong, that it would have ripped the universe apart in the first tiny fraction of a second after the Big Bang. If the quantum calculations were completely correct in their literal interpretation, space would have expanded with such immense violence that atoms, stars, galaxies, and the gentle planets we call home could never have possibly formed. The cosmos would be a dark, violently torn void, devoid of all structure and beauty. Yet, when we look up at the night sky, we see a universe that is full of structure. We see ancient, beautiful galaxies that have taken billions of years to slowly assemble. When astronomers carefully measure the actual strength of dark energy by observing the accelerating expansion of the cosmos, they find that it is incredibly weak. It is a very gentle, subtle push, just strong enough to slowly overcome the gravitational pull of matter over the course of billions of years. The actual, measured density of dark energy is staggeringly small compared to what quantum physics predicts. This colossal discrepancy between the theoretical prediction of the quantum vacuum energy and the actual observed strength of dark energy is not just a minor error. It is widely considered to be the single worst theoretical prediction in the entire history of physics. The quantum prediction is too large by a factor of 10 to the power of 120. To put that abstract concept into perspective, it is a 1 followed by 120 zeros. It is a mismatch so incredibly profound, so fundamentally baffling, that it brings our two most successful, deeply tested scientific frameworks into direct, inescapable conflict. General relativity beautifully and accurately describes the vast, curving architecture of the cosmos, while quantum mechanics perfectly and precisely dictates the chaotic, frantic behavior of the microscopic world. Both theories have been proven correct by countless experiments and observations. Yet, when they try to speak to each other about the quiet energy of empty space, they speak entirely different languages. This is the great intellectual tension of our time. It is a grand, beautiful paradox that invites us to pause and reflect. We are faced with a profound contradiction that no human mind has yet been able to resolve. But in the realm of contemplative science, we do not view this contradiction as a failure. We view it as a magnificent, open door. It is a gentle reminder from the cosmos that our current understanding, as vast and impressive as it may seem, is still incomplete. We are like children standing on the shores of an infinite ocean, holding a single glowing seashell, trying to deduce the nature of the entire deep from its small, curving shape. This colossal mystery, this gap of 120 zeros, is not a wall blocking our path. It is the very path itself. It tells us that there is something fundamentally profound about the universe that we have entirely missed. Perhaps we misunderstand the true nature of empty space. Perhaps there is a deeply hidden, undiscovered symmetry in the laws of physics that perfectly cancels out the massive quantum energy, leaving only the tiny, gentle whisper of dark energy that we observe today. Or perhaps, as some daring physicists suggest, we are only seeing a tiny fragment of a much larger, unimaginably complex multiverse. Whatever the ultimate truth may be, this quiet catastrophe of calculation forces us into a posture of intellectual humility. It demands that we let go of our absolute certainties and embrace the unknown with open, curious minds. It reminds us that the universe is not obligated to be easily understood by the minds of upright apes living on a tiny, rocky world. The mystery of dark energy, woven into the very fabric of the quantum vacuum, is an invitation to continue our eternal journey of learning. It transforms our ignorance into a powerful, driving motivation. As we sit here in the quiet contemplation of these massive, contradictory numbers, we can find a deep sense of peace. We do not need to possess all the final answers to appreciate the staggering beauty of the questions. The universe is a grand, unfolding narrative, and we have the extraordinary privilege of being conscious witnesses to its most complex, enigmatic chapters. We are participating in an endless communal effort to understand the dark and the light, the very small and the immensely large. So, let us hold on to this mystery. Let us allow the tension between quantum mechanics and the expanding cosmos to expand our own perspectives. Let us be comfortable resting in the unknown, guided by the gentle light of human curiosity. The journey is far from over. There are deeper layers of reality waiting to be gently uncovered, more profound connections waiting to be made. We will continue to explore, not to conquer the mystery, but to simply stand in its magnificent presence, observing the quiet ballet of the stars as they drift upon an endless, unseen tide. As we stand together at the edge of this magnificent intellectual canyon, gazing across a mathematical divide of 120 zeros, we might feel a momentary sense of overwhelming smallness. The cosmos has presented us with a puzzle so profound that our most trusted theories, the very pillars of modern physics, seem to falter in the cold, quiet dark. General relativity and quantum mechanics, two beautifully constructed languages used to describe the majestic architecture of the universe and the frantic dance of the subatomic realm, simply refuse to agree on the weight of nothingness. Yet, as explorers of the infinite, we do not turn away from this contradiction. We lean into it. We understand that in the grand pursuit of knowledge, a paradox is not a defeat. It is a gentle, guiding light pointing us toward a deeper, more fundamental truth that has yet to be uncovered. We embrace the tension, allowing it to fuel our insatiable curiosity rather than our fears. Before we venture further into the possible solutions to this grand cosmic riddle, I want to pause for a brief, quiet moment. I am Walter, the explorer, your companion and guide through the profound mysteries of the night sky. As we navigate this vast, beautiful journey together, I have noticed that roughly 73% of the wonderful, curious souls who watch these videos and share in these contemplative moments have not yet subscribed to our channel. If you are finding a sense of peace, intellectual safety, and deep wonder in our shared explorations of the universe, please consider gently pressing that subscribe button. It helps our small community immensely, allowing us to continue crafting these quiet stories and ensuring that we can keep looking up and wondering together for many journeys to come. Now, let us return to the dark expanse, letting our minds float among the ancient galaxies. When faced with the incomprehensible mismatch between the predicted energy of the quantum vacuum and the gentle, observed acceleration of the cosmos, theoretical physicists realized they might need to rethink their most basic assumptions. What if the cosmological constant, that elegant mathematical placeholder introduced by Albert Einstein, is not actually constant at all? Our human intuition loves stability. We find comfort in the idea of permanent, unchanging rules. We like to imagine that the invisible force pushing the universe apart is a rigid, eternal property of empty space, set in stone at the dawn of time. But the universe is a living, breathing entity, characterized by continuous evolution and dynamic change. To solve the mystery of dark energy, some of the most brilliant minds in cosmology have proposed a beautiful alternative: a mysterious, fluctuating energy field known as quintessence. The name itself is steeped in ancient poetry and philosophy. In classical antiquity, philosophers believed the cosmos was composed of four fundamental elements: earth, water, air, and fire. But they also imagined a fifth element, a pure, ethereal substance that filled the heavens and made up the stars. They called it the quintessence. Today, modern physicists use this beautiful, ancient word to describe a dynamic, invisible field that might be stretching the very fabric of reality. To truly understand what a field is in the context of physics, we must gently shift our perspective. Do not think of matter as solid, isolated objects bouncing around in an empty void. Instead, imagine the universe as a vast, infinite ocean. A field is like a property of that ocean, a condition that exists at every single point in space and time. Consider the temperature in the quiet room where you are currently resting. At every point in the air around you, there is a specific temperature. It might be slightly warmer near the window and cooler near the floor, but the temperature exists everywhere. It is a field. Or think of a gentle, invisible magnetic field surrounding a common magnet, silently exerting its influence on the iron filings scattered around it. Quintessence is proposed to be a scalar field, an invisible, intangible presence that permeates the entire cosmos, interacting with the fabric of space itself. But unlike a simple cosmological constant, which remains forever locked at the exact same strength, a quintessence field is dynamic. It can change. It can evolve. It can flow and shift over the vast, unfathomable stretches of cosmic time. If dark energy is indeed composed of quintessence, the implications are staggering and deeply moving. It means that the acceleration of the universe is not a fixed mechanical destiny, but a fluid, unfolding narrative. Billions of years ago, in the ancient youth of the cosmos, this field might have possessed a completely different strength. It might have been quiet and dormant, allowing the familiar force of gravity to gently pull the primordial clouds of hydrogen and helium together, sculpting the magnificent, glowing islands we call galaxies. As the universe matured and expanded, this field might have slowly awakened, its repulsive energy gradually increasing until it overcame the collective gravitational pull of all the matter in existence, ushering in the era of accelerated expansion we observe today. And what of the future? If dark energy is dynamic, the ultimate fate of the entire cosmos is unwritten. If the quintessence field continues to grow stronger and stronger, it could eventually push everything apart with terrifying force. overcoming not just the gravity between galaxies, but the nuclear forces holding atoms together, leading to a theoretical end known as the Big Rip. But if the field eventually weakens, or slowly decays back into other forms of energy, the universe might gently coast into a peaceful, eternal expansion, or even slowly, softly begin to contract. We do not know which of these futures awaits us, and that is a beautiful mystery to hold in our minds. But science does not merely rest in philosophical speculation. It actively seeks to gently uncover the truth through rigorous, meticulous observation. To determine whether dark energy is a rigid constant or a dynamic, breathing field like quintessence, humanity has embarked on some of the most ambitious observational quests in our history. We are building magnificent instruments, mechanical extensions of our own insatiable curiosity, and sending them out into the cold, silent dark. Consider the European Space Agency's Euclid mission, a breathtakingly complex space telescope launched to study the dark universe. Euclid is drifting 1,000,000 miles away from our home planet, staring out into the infinite depths with unparalleled precision. Its mission is to map the shape, position, and movement of billions of galaxies, creating the largest, most accurate three-dimensional map of the cosmos ever attempted. By observing how the distribution of these ancient galaxies has changed over the last 10 billion years, Euclid acts as a cosmic time machine. It allows scientists to trace the exact history of the universe's expansion, searching for any subtle, microscopic variations in the strength of dark energy over deep time. Similarly, the National Aeronautics and Space Administration is preparing to launch the Nancy Grace Roman Space Telescope. This incredible observatory will possess a field of view 100 times greater than the legendary Hubble Space Telescope, allowing it to capture sweeping panoramic vistas of the deep sky in a single glance. It will measure the faint, stretched light of millions of distant supernovas and analyze the subtle distortions in the shapes of background galaxies caused by the invisible presence of dark matter. These rigorous, incredibly precise measurements from both Euclid and the Roman Space Telescope are not just simple data collection. They are our attempt to read the subtle handwriting of the cosmos. They are our way of asking the universe, with profound respect and humility, whether the dark energy that surrounds us is a permanent fixture of the vacuum, or a fleeting, evolving whisper of quintessence. If these magnificent missions detect even the slightest fluctuation, the tiniest hint that dark energy has changed its strength over the eons, it will completely revolutionize our understanding of physics, opening up entirely new, uncharted realms of knowledge. As we wait for these answers to gently arrive over the coming years and decades, we must cultivate a deep appreciation for the state of not knowing. The great physicist Richard Feynman once beautifully articulated this sentiment when he said, "I would rather have questions that cannot be answered than answers that cannot be questioned." This is the true essence of the scientific spirit. It is the ability to stand before the vast, infinite mystery of the cosmos, to acknowledge our own profound limitations, and to feel a sense of joyful wonder rather than anxiety. We are entirely comfortable resting in this quiet tension. The fact that we do not fully understand what makes up nearly 70% of our universe is not a source of despair. It is a source of limitless inspiration. It means the journey of discovery is far from over. It means there are still grand adventures of the mind waiting for future generations of thinkers, dreamers, and explorers. We are part of a continuous, unbroken chain of human curiosity, reaching back to our ancestors who first looked up at the night sky in awe, and stretching forward to the minds that will eventually unravel the enigma of the quantum vacuum. When you step outside tonight and look up at the silent, twinkling stars, remember that the dark spaces between them are not empty. They are filled with an invisible, majestic power that is shaping the ultimate destiny of everything you can see. Whether that power is an eternal constant of nature, a bubbling artifact of the quantum foam, or a dynamic, shifting field of quintessence, it connects us all. It reminds us that we are embedded in a universe that is far grander, far stranger, and far more beautiful than our everyday experiences could ever suggest. We are tiny, fragile beings, bound to a small rock by the gentle pull of gravity. Yet we possess the extraordinary ability to cast our minds across billions of light years, to probe the smallest subatomic particles, and to ponder the invisible forces that govern the infinite. This is our quiet triumph. This is the profound beauty of our existence. Let the mystery of dark energy wash over you like a calm, silent tide. Feel the intellectual safety of knowing that it is perfectly acceptable to be surrounded by the unknown. In the shadows of our ignorance, the brightest sparks of wonder are born. The cosmos does not demand that we understand it perfectly. It simply invites us to observe, to question, and to marvel at its incredible complexity. Our exploration of the dark universe has brought us face to face with the limits of our current theories, but the path ahead remains open and brightly illuminated by our collective desire to learn. We will gently push forward, delving deeper into the fabric of space and time, seeking the quiet harmonies that might eventually bridge the gap between the quantum world and the expanding cosmos. The universe holds its secrets closely, but it reveals them slowly, patiently, to those who are willing to look with a quiet, persistent reverence. Let us gently resume our voyage, drifting once more into the profound silence of the cosmos. We have spoken of the bubbling, restless ocean of the quantum vacuum, and the elegant, dynamic fields of quintessence that might weave through the dark. But to truly grasp the mystery of what dark energy might be made of, we must look closer at the invisible architecture that supports all of reality. In the language of modern physics, the universe is not made of tiny, solid objects bouncing through an empty void. Instead, it is composed of fields. Imagine an infinite, quiet, perfectly still body of water spanning the entire cosmos. This is a quantum field. When energy gently plucks at this field, a ripple forms, and we perceive that tiny, fleeting ripple as a particle. Every electron in your body, every photon of light traveling from a distant ancient star, is simply a localized vibration in one of these underlying infinite fields. The vacuum of space is not truly empty. It is the silent, overlapping presence of all these fields, resting in their lowest possible energy state, waiting in the absolute dark. Before we delve deeper into this invisible, vibrating tapestry, I want to take a brief, quiet moment to speak with you directly. I am Walter, the Explorer, your companion on this journey through the grandest mysteries of space and time. As we share this gentle, contemplative space together, I notice that 73% of the curious souls who watch these videos have not yet subscribed to our channel. If you find comfort, intellectual safety, and a deep sense of wonder in these quiet explorations, please consider subscribing. It helps our small community immensely, allowing us to continue crafting these meditative stories and ensuring we can keep exploring the boundless universe together. Now, let us return to the dark, quiet expanse. When a quantum field is perfectly calm, it is still not entirely devoid of energy. Because of the inherent uncertainty that governs the microscopic realm, these fields cannot sit completely still. They continuously hum with a baseline level of activity known as zero-point energy. Think of a softly plucked guitar string that never truly stops vibrating, its final, lowest hum lingering forever in the air, maintaining a fragile, invisible presence. Now, imagine billions upon billions of these invisible strings, representing all the fundamental forces and particles of nature, humming together in the profound silence of the vacuum. This combined, endless vibration is what gives empty space its weight, its substance, and, perhaps, its subtle, repulsive push. But the mystery deepens when we try to understand how these microscopic vibrations, these tiny ripples in the quantum fields, manage to orchestrate the grand, accelerating expansion of the entire cosmos. How does the unimaginably small dictate the fate of the incomprehensibly large? To find the answer, or at least the edge of our current understanding, we must look back to the very dawn of time, to the oldest light in the universe. We must gently turn our gaze to the cosmic microwave background radiation, a relic from an era long before the Earth, the Sun, or even the most ancient galaxies had formed. Imagine the universe just 380,000 years after the Big Bang. It was a time long before the first stars had ignited, a time before the ancient galaxies had begun to take their majestic spiral and elliptical shapes. The cosmos was filled with a thick, glowing fog of plasma, unimaginably hot and incredibly dense. As the universe slowly, gently expanded, it cooled. And in one beautiful, quiet moment, the temperature dropped just enough for electrons to bind to atomic nuclei. The fog finally cleared. Light was suddenly free to travel unhindered through the vast, expanding dark. That first, ancient flash of light has been traveling through the void for over 13 billion years, stretching and cooling as the fabric of space itself has expanded. Today, it washes over our small, rocky planet not as visible light, but as a faint, gentle whisper of microwave radiation coming from every conceivable direction in the night sky. It is the afterglow of creation, a perfect, quiet snapshot of the infant cosmos. By studying this ancient light, scientists can measure the fundamental properties of the universe with breathtaking precision, reading the very history of existence written in faint photons. Humanity has sent magnificent mechanical explorers into the cold dark to listen to this cosmic whisper. Missions like the Wilkinson Microwave Anisotropy Probe, launched by the National Aeronautics and Space Administration, and the Planck satellite, launched by the European Space Agency, have mapped the cosmic microwave background with incredible, meticulous detail. They looked for tiny, microscopic fluctuations in the temperature of this ancient light, subtle differences that represent the primordial seeds from which all the massive superclusters of galaxies eventually grew over billions of years. But these quiet, distant observations revealed something far more profound about the very geometry of space itself. When scientists analyzed the intricate, mottled patterns in the cosmic microwave background, they discovered that our universe is completely, perfectly flat. In the mind-bending language of modern cosmology, a flat universe does not mean it is a two-dimensional sheet like a piece of paper. It means that on the grandest, most infinite scales, the normal rules of geometry apply perfectly. Parallel lines will remain parallel forever, never converging and never diverging, stretching outward into the endless dark. For the universe to possess this perfect, delicate geometric flatness, the total amount of energy and matter within it must add up to a very specific, critical density. This is where the grand, beautiful puzzle of dark energy truly solidifies, forcing us to confront the limitations of our own intuition. When astronomers meticulously counted up all the ordinary matter in the universe, all the shining stars, the drifting dust, the swirling gas clouds, and the supermassive black holes sitting in silence at the centers of ancient galaxies, it amounted to barely 5% of that critical density. We, and everything we have ever seen, touched, or interacted with, are merely a 5% afterthought in the grand cosmic recipe. When they factored in the invisible gravitational pull of dark matter, the unseen scaffolding that holds rotating galaxies together, it added another 27%. But that still left a massive, gaping hole in our understanding. Approximately 68% of the universe was simply missing from the ledger. The mathematical equations of general relativity demanded that something else must exist. Something with enough energy to make the universe perfectly flat, yet completely invisible and untouchable by our instruments. That missing piece, the dominant ingredient of reality itself, is dark energy. The gentle, ancient light of the cosmic microwave background proves that this mysterious force is not a mathematical error, a glitch in our telescopes, or a mere illusion. It is an absolute physical necessity. It is the very thing that balances the cosmic scales, the silent architect of the universe's perfect geometry. So we return, once again, to the profound tension between the vast, expanding cosmos and the microscopic, boiling quantum realm. The ancient light of the Big Bang demands dark energy to exist, to maintain its beautiful flatness, and the bubbling quantum vacuum naturally provides a source of energy hidden within the empty dark. Yet, as we have seen, the numbers simply do not align. The quantum physics prediction of this vacuum energy is vast, chaotic, and unimaginably violent, while the observed reality of dark energy is subtle, weak, and incredibly gentle. This colossal mismatch of 120 zeros is not a cause for scientific frustration, but rather a profound invitation to wonder. It tells us that nature is holding on to a beautiful secret, a much deeper layer of reality where the laws of the very large and the very small finally harmonize in a perfect, quiet symphony that we have not yet learned to hear. Consider the sheer humility required to accept this staggering reality. We, the curious inhabitants of a fragile blue world, have built mechanical eyes that can see the afterglow of creation. We have developed mathematics that can describe the invisible vibrations of absolute nothingness. Yet, the cosmos gently reminds us that our knowledge is just a small, flickering candle in an infinite, dark room. The discrepancy between the quantum foam and the quiet acceleration of the galaxies is a beautiful testament to the absolute limits of current human understanding. It shows us that science is not a closed book of absolute facts, but a continuous, living journey of exploration. The fact that the universe is dominated by an invisible energy that we can neither see nor truly comprehend does not diminish our place within it. It elevates our quest. It means that the universe is still full of magic, still brimming with profound secrets waiting to be gently uncovered by curious minds. Our human brains are uniquely equipped to ponder these vast mysteries, to feel the emotional weight of the infinite, and to find peace in the spaces where our knowledge ends and our imagination begins. We are explorers standing at the threshold of this grand unification, peering into the great unknown with a sense of respectful awe rather than fear. The mystery of what dark energy is made of according to quantum physics remains beautifully unsolved, an endless journey of the mind that invites us to keep looking up. As we embrace this intellectual humility, we find a deep, comforting peace. We do not need to master the universe to appreciate its staggering majesty. We simply need to observe, to ask the profound existential questions, and to let the vastness of the unknown wash over us like a gentle tide. Let the infinite silence of the cosmos fill you with an abiding sense of wonder. For in our gentle pursuit of these ancient, universal mysteries, we are truly connecting with the very heart of the cosmos itself. We are star stuff, contemplating the invisible forces that shape our destiny, drifting quietly on the currents of an endless, beautiful mystery. Have you ever sat in a quiet room, perhaps as the evening shadows slowly lengthen, and listened to the fading resonance of a plucked guitar string? Long after the initial sound has dissipated, a faint, almost imperceptible vibration lingers in the air. It is a gentle reminder that stillness is often just an illusion, masking a deeper, unseen motion. What if I told you that this simple, everyday experience might hold the very key to understanding the greatest mystery in the entire cosmos? We have journeyed through the expanding universe. We have waded into the bubbling ocean of the quantum vacuum, and we have stood at the edge of the mathematical abyss where our best theories fail to predict the gentle push of dark energy by a factor of 1 followed by 120 zeros. To cross this abyss, we must abandon our traditional ways of picturing reality. We must stop thinking of the fundamental building blocks of the universe as tiny, solid dots. Instead, quantum physics invites us to imagine a universe built entirely out of music. It invites us to consider the breathtaking framework known as string theory. Before we tune our ears to this ancient cosmic symphony, I want to take a brief, quiet moment to speak with you directly. I am Walter, the Explorer, your gentle guide through the vast, awe-inspiring mysteries of space and time. As we share this contemplative journey together, navigating the profound wonders of the night sky, I notice that 73% of the curious souls who watch these videos have not yet subscribed to our channel. If you find comfort, intellectual safety, and a deep sense of peace in these quiet explorations, please consider subscribing. It helps our small community immensely, allowing us to continue crafting these meditative stories and ensuring we can keep wondering together. Now, let us return to the dark, quiet expanse and listen to the hidden music of reality. String theory proposes that if you were to take any particle, an electron, a quark, or even the ghost-like neutrino, and zoom in on it, far past the limits of any microscope, down to a scale so unimaginably small that it makes an atom look like an entire galaxy, you would not find a solid sphere. You would find a tiny, vibrating loop of pure, concentrated energy. This microscopic loop is the ultimate foundational element of everything that exists. Just as the different vibrations of a cello string produce different musical notes, the different ways these microscopic cosmic strings vibrate determine the properties of the particles they form. In this beautifully poetic framework, the entire universe, from the ancient swirling galaxies to the delicate structure of a fallen leaf, is nothing more than a magnificent, complex symphony played on these invisible, fundamental strings. But how does this cosmic music help us understand the silent, repulsive force of dark energy? To find the connection, we must look at the stage upon which these strings vibrate. In our everyday experience, we move through 3 dimensions of space and 1 dimension of time. However, the mathematics of string theory demand something entirely counterintuitive. The equations simply do not work unless the strings are vibrating in a universe that possesses extra, hidden dimensions. Specifically, the most widely studied versions of string theory require 10 dimensions to function properly. This concept challenges our basic perception of reality in the most profound way. Where are these extra dimensions? Why can we not feel their gentle presence in the dark? Theoretical physicists suggest that while our familiar 3 spatial dimensions expanded massively during the Big Bang, creating the vast, observable cosmos we see today, the extra dimensions remained incredibly small. They are curled up, tightly folded back onto themselves, compacted into unimaginably complex, beautiful geometric shapes. These hidden, microscopic landscapes exist at every single point in our visible universe. The extra dimensions of string theory are curled up so tightly that they are completely invisible to us, existing on the Planck length, a scale of roughly 10 to the power of negative 35 meters. It is a realm of absolute, silent, microscopic complexity. Here, in the deeply hidden architecture of these curled-up dimensions, lies a potential, profound answer to the mystery of dark energy. The exact shape, size, and topology of these hidden dimensions dictate how the fundamental strings can vibrate. Remember the boiling, restless sea of virtual particles that constantly pop in and out of existence, giving empty space its intrinsic energy. In the framework of string theory, this vacuum energy is heavily influenced, deeply sculpted, by the microscopic contours of the extra dimensions. The mathematical equations suggest that there are perhaps 10 to the power of 500 different ways these extra dimensions can be folded and arranged. Each unique folding produces a different amount of vacuum energy. For decades, this unimaginably vast landscape of possibilities was seen as a theoretical crisis. If string theory allows for 10 to the power of 500 different possible universes, each with its own unique amount of dark energy, how can it ever explain why our specific universe looks the way it does? Slowly, a profound philosophical shift began to occur. What if this mathematical landscape is not a flaw, but a description of actual physical reality? What if our visible universe, with its billions of ancient galaxies and its gentle, accelerating expansion, is just one tiny, quiet bubble in an infinite, boiling multiverse? In this mind-bending scenario, the cosmos is an eternal expanse where different regions of space and time have different extra dimensions curled up in different ways. Somewhere in this infinite, sprawling multiverse, purely by the laws of statistical probability, there must exist a quiet, gentle bubble where the extra dimensions are folded in precisely the right way to produce a tiny, incredibly weak, positive, dark energy. A dark energy just gentle enough to allow gravity to pull matter together into swirling galaxies over billions of years, and just persistent enough to slowly push those galaxies apart over the long, majestic eons of cosmic time. We live in this specific, gentle bubble because we could not possibly exist in any other. This concept invites a deep, humbling sense of wonder. It suggests that the incredibly precise tuning of our universe is an inevitable consequence of an infinite reality. The discrepancy of 120 zeros is resolved by realizing that we are looking at just one tiny, hospitable room in a mansion of infinite, uninhabitable chambers. This realization fundamentally transforms our relationship with the unknown. The invisible, repulsive force of dark energy that surrounds us, pushing the ancient galaxies toward the cosmic horizon, might simply be the gentle vibration of the specific geometric shape of our local reality. We are sitting in a quiet room, listening to a delicate chord played on the invisible strings of the universe, a chord that has allowed us to open our eyes and marvel at the infinite darkness. To prove the existence of these extra dimensions is currently beyond the reach of our mechanical instruments. The European Organization for Nuclear Research operates the Large Hadron Collider, crashing particles together to peer into the fundamental fabric of reality. While these rigorous experiments have revealed much, they have not yet found the elusive whispers of extra dimensions. The energies required to probe the Planck length are far beyond our capabilities. We must rely on the elegant mathematics and the beautiful consistency of the theories. We are navigating the dark, quiet ocean of the unknown with the compass of human reason. As we gently float in this space of contemplation, let the vastness of these ideas wash over you. We have evolved on a tiny, rocky planet, and yet we have developed the capacity to conceptualize the 10 dimensions of string theory. Our physical bodies may be confined to this one small, gentle bubble, but our minds have already touched the infinite. The mystery of dark energy is a mirror, reflecting our own profound capacity for wonder, our insatiable need to understand the quiet, dark spaces of the cosmos. The universe is a magnificent, intricate symphony, and we are both the audience and the instruments, resonating with the ancient, quiet music of the stars. Have you ever stood before a perfectly still, quiet lake at the edge of the evening, watching the reflection of the ancient trees and the distant, fading stars on the surface of the water? When you look into that gentle mirror, you see a world that appears to possess profound depth. You see the towering silhouettes of the pines reaching downward, and the twinkling lights of the cosmos stretching infinitely below you. Yet, if you were to reach out and touch it, your hand would meet only a flat, two-dimensional surface. The magnificent depth you perceive is, in a physical sense, a beautiful illusion woven by light. In our continuing quest to understand the vast, expanding cosmos and the elusive nature of dark energy, some of the most brilliant minds in theoretical physics are beginning to wonder if our entire universe might be a grand, cosmic version of that quiet lake. They are asking a question that seems almost indistinguishable from a beautiful dream. What if the 3 dimensions of space that we move through every single day are not fundamentally real, but are instead a magnificent projection arising from a deeper, flatter reality? To bridge the monumental gap between the chaotic, microscopic world of quantum physics and the majestic, accelerating expansion of the cosmos, we must be willing to let go of our most deeply held intuitions about the very nature of space and time itself. Before we wade deeper into these mind-bending waters and explore the holographic nature of our universe, I want to take a brief, quiet moment to speak with you. I am Walter, the Explorer, your gentle guide on this journey through the most profound mysteries of the dark, infinite night sky. As we share this contemplative space, seeking peace and wonder in the stars, I have noticed that roughly 73% of the wonderful, curious souls who join these explorations have not yet subscribed to our channel. If you find intellectual safety, comfort, and a sense of belonging in these quiet, cosmic stories, please consider taking a moment to subscribe. It helps our small community immensely, allowing us to continue creating these meditative journeys and ensuring that we can keep looking up together, exploring the boundless unknown as a family of stargazers. Now, let us return to the quiet expanse and gently peel back the fabric of reality. To understand this radical, breathtaking concept, we must turn our attention away from the empty voids of space and look toward the most extreme, enigmatic objects in the entire cosmos: black holes. For a long time, scientists viewed black holes as ultimate cosmic destroyers, dark, silent monsters where gravity is so overwhelmingly powerful that nothing, not even a single photon of light, can ever escape. They were thought to be bottomless pits where matter and information simply vanish from the universe forever. But in the 1970s, the brilliant physicist Stephen Hawking, building on the profound insights of Jacob Bekenstein, made a discovery that sent a quiet shockwave through the scientific community. They realized that black holes are not completely black, and they are not entirely silent. Through a complex interplay of quantum mechanics and general relativity near the edge of the black hole, a boundary known as the event horizon, these dark spheres actually emit a very faint, gentle glow of thermal radiation. But the most astonishing part of their discovery was not the radiation itself. It was what their equations revealed about the fundamental nature of information. In physics, information refers to the exact quantum arrangement of all the particles that make up an object. Bekenstein and Hawking proved that if you drop an object, say a book or a small rocky planet, into a black hole, the quantum information describing that object is not lost in the dark, bottomless center. Instead, the information is perfectly preserved, encoded like a microscopic watermark on the two-dimensional surface of the black hole's event horizon. And, crucially, they found that the total amount of information a black hole can hold is directly proportional not to its three-dimensional volume, but to its two-dimensional surface area. Imagine trying to store all the data of a massive encyclopedic library. Common sense tells you that you need a large, three-dimensional room to hold all those books. But the physics of black holes dictates that you only need to measure the surface area of the walls, floor, and ceiling to know exactly how much data can fit inside. The three-dimensional space inside the black hole is entirely described by the two-dimensional boundary surrounding it. This profound realization gave birth to what physicists call the holographic principle. It is a concept that challenges the very foundation of how we experience reality. A hologram is a two-dimensional surface that encodes all the visual information necessary to project a fully three-dimensional image. The holographic principle boldly suggests that the entire universe might operate in exactly the same way. What if the three dimensions of space we gently move through, the vast, ancient voids between the galaxies, the spinning planets, and our own physical bodies, are all a complex holographic projection? In this mind-bending framework, the true fundamental reality of the cosmos exists on a distant, lower-dimensional boundary that surrounds our universe. A theoretical edge where the microscopic laws of quantum mechanics are painted in absolute, intricate perfection. The gravity we feel, the passage of time we experience, and the three-dimensional space we inhabit are not fundamental ingredients of the universe. They are emergent phenomena, beautiful illusions arising from the complex quantum mathematics written on that silent, distant surface. If space itself is not a fundamental property of the universe, but rather an emergent illusion created by a network of quantum information, then we must drastically reevaluate our understanding of dark energy. For decades, we have been trying to understand dark energy as a physical substance, a bubbling sea of virtual particles in the quantum vacuum, or a dynamic, shifting field of quintessence that fills the empty spaces. But if space is emergent, then perhaps dark energy is not a thing at all. Perhaps the accelerating expansion of the cosmos is not caused by an invisible force pushing the ancient galaxies apart. Instead, it might be an inevitable thermodynamic consequence of how quantum information behaves on the boundary of our universe. In the quantum realm, there is a profound phenomenon known as entanglement. When two particles become entangled, their quantum states are permanently linked, regardless of how much physical distance separates them. If you gently measure the state of one particle, you instantaneously know the state of its distant partner, even if it is on the other side of the observable universe. Some theoretical physicists now propose that quantum entanglement is the very thread that weaves the fabric of space together. In this breathtaking view, distance is just a measure of how entangled different quantum systems are. Regions of space that are highly entangled are physically close together, while regions with very little entanglement are separated by vast, dark, cosmic voids. As the universe evolves over billions of years, the total amount of quantum information and the complexity of its entanglement naturally increase. According to the laws of thermodynamics, systems tend to move from a state of order to a state of disorder, a concept known as entropy. As the entropy of the quantum information on the holographic boundary of our universe increases, the emergent three-dimensional space must adapt. To accommodate this ever-growing web of complex quantum entanglement, the fabric of space itself must stretch and expand. In this deeply contemplative framework, the mystery of dark energy transforms into something entirely unexpected and profoundly beautiful. The accelerating expansion of the universe is not an active, violent force tearing the cosmos apart. It is simply the quiet, natural cost of existence. It is the universe breathing, expanding to make room for the increasing complexity of its own quantum information. The discrepancy of 120 zeros that plagues our standard theories might simply be the result of using the wrong language to describe the cosmos. We have been trying to calculate the weight of a shadow, the energy density of a projection, rather than reading the fundamental code written on the boundary of reality. We have been looking at the reflection on the quiet lake, trying to measure the physical depth of the water, when we should have been studying the gentle ripples of light on the two-dimensional surface. This holographic perspective requires an immense amount of intellectual humility. It asks us to accept that our human senses, which evolved to help us navigate the gentle surface of a small, rocky planet, are completely blind to the true, fundamental nature of the cosmos. We are creatures living inside a magnificent, ancient projection, trying to deduce the mechanics of the projector. Yet, there is a deep, abiding peace to be found in this realization. It means that we are deeply, inextricably connected to the furthest edges of the infinite universe. Every atom in your body, every thought in your mind, every gentle breath you take, is encoded in the complex web of quantum information that forms the foundation of reality. We are not separate from the mystery. We are the mystery itself, experiencing its own vastness. The universe is a masterclass in subtlety and grand design, and we are its most eager, curious students. When you look up at the night sky, past the glowing moon and the ancient, silent stars, remember that the dark spaces between them might not be empty voids at all. They might be the woven tapestry of quantum entanglement, the very fabric of an emergent reality, stretching and breathing as the universe continues to write its magnificent, infinite story. We will continue to explore these depths, gently pushing the boundaries of our imagination, guided by the enduring light of human curiosity and the profound, comforting silence of the cosmos. Have you ever held a handful of dry, ancient sand and watched as it slipped silently through your fingers, returning to the earth? From a distance, a sand dune appears as a perfectly smooth, continuous, flowing wave, sculpted by the gentle winds of time. But when you look closely, when you bring it right up to your eyes, you see that it is not a single, solid object at all. It is made of countless individual grains, tiny fragments of ancient mountains that have been ground down by the relentless, quiet machinery of the universe. For our entire journey together, we have treated the vast, dark emptiness of space as a continuous, unbroken fabric. We have imagined it as a smooth, stretching canvas upon which the majestic galaxies are painted, or as an infinite, calm ocean where the fundamental quantum fields gently vibrate and hum. But, as we search for the ultimate truth about dark energy, a group of profoundly imaginative physicists are asking a question that challenges the very foundation of this assumption. What if space itself, the very stage upon which the cosmic drama unfolds, is not smooth at all? What if, when you zoom in past the tiny, frantically boiling virtual particles of the quantum vacuum, past the unimaginably small vibrating loops of string theory, you discover that the void is made of discrete, individual, microscopic grains? This beautiful, counterintuitive idea forms the heart of a theoretical framework known as loop quantum gravity. And it might just hold the key to understanding the invisible force that is gently pushing the universe apart. Before we dive into the microscopic, granular structure of the cosmos, I want to take a brief, quiet moment to speak with you directly. I am Walter, the explorer, your companion and gentle guide through the profound, unfolding mysteries of space and time. As we share this contemplative journey together, navigating the beautiful unknown, I have noticed that roughly 73% of the wonderful, curious souls who watch these videos have not yet subscribed to our channel. If you find comfort, intellectual safety, and a deep sense of wonder in these quiet explorations, please consider subscribing. It helps our small community immensely, allowing us to continue crafting these meditative stories and ensuring we can keep exploring the boundless universe together. Now, let us return to the dark, quiet expanse and look closer at the fabric of reality than we ever have before. In the elegant mathematics of loop quantum gravity, there is no such thing as infinite, continuous space. Instead, space is woven from tiny, finite loops of fundamental energy, interlocking and connecting with one another in a magnificent, invisible, three-dimensional mesh. These loops are so unimaginably small that it would take more of them to fill a single cubic centimeter of empty space than there are cubic centimeters in the entire observable universe. It is a scale of existence that completely defies human comprehension, existing at the absolute, mathematical limit of physical reality known as the Planck length. When you move your hand through the air, you are not gliding through a smooth, empty void. You are transitioning from one microscopic, granular unit of space to the next, like a digital character moving across the pixels of a high-resolution screen. In this profound framework, space is not a container that holds the universe. Space is the universe. It is a physical, structured entity, built from the ground up by these ancient, invisible, interlocking loops. If the void is fundamentally granular, then our understanding of how gravity operates must be entirely rewritten. Albert Einstein beautifully described gravity as the smooth, continuous curving and warping of space and time around massive objects, like ancient stars and wandering planets. But in loop quantum gravity, that smooth curvature is just an illusion created by the collective, macroscopic behavior of trillions upon trillions of microscopic, interlocking loops. Much like the smooth surface of a sand dune is created by billions of individual grains. And here is where the profound, quiet mystery of dark energy beautifully intersects with this granular view of reality. If space is made of individual, finite pieces, then it cannot be infinitely compressed, and its energy cannot be infinitely dense. The chaotic, violent calculations of the standard quantum vacuum, the ones that predicted an energy so immense that it would have destroyed the infant universe, might simply be the result of a mathematical error. We were calculating the energy of a smooth, infinite continuum, but the universe is actually built of tiny, discrete, finite blocks. When theoretical physicists attempt to calculate the properties of space using the mathematics of loop quantum gravity, a truly astonishing, elegant picture begins to emerge. Because these microscopic loops of space cannot be compressed beyond a certain fundamental limit, they naturally exert a very slight, microscopic repulsive force against one another. It is as if the very fabric of reality has a built-in elasticity, a fundamental resistance to being crushed. On the small scale of our everyday lives, or even on the scale of our solar system, this tiny, inherent repulsion is completely unnoticeable, completely overwhelmed by the familiar, comforting pull of ordinary gravity. But when you accumulate this incredibly weak, repulsive bounce over the vast, unimaginably huge expanses of empty space that separate the great superclusters of galaxies, it begins to add up. The cumulative effect of trillions of light-years of these granular, interlocking loops slightly pushing against each other might be the exact phenomenon that we perceive as dark energy. The accelerating expansion of the cosmos might not be a mysterious, newly added force. It might simply be the natural, inherent elasticity of granular space slowly unfolding over the majestic eons of cosmic time. This elegant solution brings a profound sense of harmony to the great intellectual tension we have been exploring. It suggests that the monumental mismatch between the violent predictions of quantum mechanics and the gentle observed acceleration of the cosmos is not a fundamental paradox, but a consequence of our own incomplete understanding. We were trying to understand the ocean without realizing it was made of individual drops of water. By recognizing the granular nature of the void, the mathematics begin to heal, and the extreme infinite numbers naturally fall away, leaving behind the small, gentle, pervasive push that beautifully matches our observations of the night sky. The universe, in its deep, quiet wisdom, seems to have woven the mechanism of its own expansion directly into the foundational threads of its existence. Dark energy is not a ghostly presence haunting the void. It is the very architecture of the void itself, quietly stretching its ancient, granular muscles. But loop quantum gravity asks us to take one more profound, deeply unsettling, and yet beautiful conceptual leap. If space is made of discrete, individual pieces, what about time? Our human experience is entirely bound to the relentless, forward-flowing river of time. We remember the past, we experience the fleeting present, and we look toward the unknown future. But in the deepest equations of loop quantum gravity, time as a fundamental, independent dimension simply ceases to exist. At the absolute microscopic level of these interlocking loops, there is no ticking clock, no universal metronome keeping the beat for the cosmos. The loops do not exist within time. They create the illusion of time through their complex, sequential interactions with one another. Change happens, particles move, and the universe expands. But there is no external timeline governing these events. Time is an emergent property, a gentle, macroscopic illusion created by the shifting, rearranging dance of the fundamental grains of space. As we gently float together in this space of grand, unifying ideas, let the vastness of the mystery envelop you like a warm, comforting blanket. Feel the profound intellectual safety of knowing that the universe is far more intricate, more delicate, and more unimaginably beautiful than our ancestors ever dared to dream. The invisible, repulsive force that pushes the ancient galaxies apart is not a cold, mechanical necessity. It is a vital, breathing component of the cosmic architecture, a necessary elasticity woven directly into the very fabric of existence. Every single time you step outside and look up at the quiet, silent stars, you are not just looking at distant fires. You are looking at the macroscopic manifestation of a deeply hidden, microscopic symphony. We will continue our gentle exploration together, stepping carefully further into the unknown, carrying with us the profound humility of our limited perspective and the boundless, joyful energy of our endless curiosity. The great mystery remains, vast, dark, and ancient, offering a silent, continuous invitation to keep wondering, to keep learning, and to keep finding our peaceful, quiet place within the infinite, granular dark. Have you ever watched a single, fragile autumn leaf detach from a high branch and drift slowly toward the earth? In that brief, silent descent, there is a profound story about beginnings, endings, and the inescapable flow of time. We understand instinctively that everything in our daily experience has a season. Stars ignite, burn furiously for billions of years, and eventually fade into the quiet dark. Planets form from swirling disks of ancient dust, harbor the delicate sparks of life for a fleeting moment, and are ultimately swallowed by their dying suns. But what about the cosmos itself? When we look out into the infinite, stretching dark, filled with the gentle light of 1,000,000,000,000 galaxies, we must inevitably ask the ultimate, perhaps most humbling question of all. How does the universe end? For a long time, humanity believed that gravity, the familiar comforting force that holds our feet to the ground, would eventually halt the expansion of space, pulling everything back together in a spectacular, fiery reversal of the Big Bang. But the discovery of dark energy, the invisible, repulsive force hidden within the quantum vacuum, has completely rewritten the final chapter of the cosmic story. Because dark energy is pushing the universe apart, the fate of all reality depends entirely on what this mysterious quantum-driven force decides to do in the unimaginably distant future. Before we journey to the very end of time to witness the final quiet acts of the cosmic play, I want to take a brief, gentle moment to speak with you. I am Walter, the explorer, your dedicated companion on this journey through the deepest, most profound mysteries of the universe. As we share this peaceful, contemplative space together, navigating the vast unknown, I have noticed that exactly 73% of the wonderful, curious souls who watch these videos have not yet subscribed to our channel. If you find comfort, intellectual safety, and a deep sense of wonder in these quiet explorations of the night sky, please consider subscribing. It helps our small community immensely, allowing us to continue crafting these meditative stories and ensuring we can keep exploring the boundless cosmos together. Now, let us return to the dark, quiet expanse and cast our minds forward into the deep, uncharted waters of eternity. If the dark energy that fills the vacuum of space is truly a cosmological constant, as Albert Einstein first proposed and as many quantum physicists suspect, then its density will remain perfectly, unwaveringly the same forever. As the universe continues to expand, it will not collapse. Instead, it will simply grow colder, darker, and more profoundly silent. This scenario is known as the heat death of the universe. Imagine looking up at the night sky billions of years from now. The magnificent, swirling galaxies that currently illuminate the dark will have been pushed so incredibly far away by the relentless expansion of space that their ancient light will no longer be able to reach us. The night sky will be completely, entirely black, devoid of any distant, twinkling companions. The stars within our own galaxy will slowly exhaust their nuclear fuel, fading one by one like dying embers in a cold hearth. Eventually, even the most massive, silent black holes will slowly evaporate through the gentle leakage of Hawking radiation, dissolving back into the bubbling quantum foam. The universe will reach a state of absolute, unbreakable equilibrium, a quiet, infinite expanse where no more warmth can be generated, and no more life can exist. It is a destiny of profound, inescapable stillness, but the quantum world is rarely so simple, and it rarely adheres to our expectations of eternal, unchanging stillness. What if the dark energy driving the expansion is not a permanent, unyielding constant? What if it is a dynamic, shifting phantom energy, a quantum field whose repulsive strength actually increases as time goes on? In this deeply unsettling scenario, the accelerating expansion of the cosmos eventually becomes a runaway train. The invisible push of the quantum vacuum grows stronger and stronger, eventually overpowering every other force in nature. First, it will overcome the gravitational bonds that hold the great superclusters of galaxies together, isolating them in the dark. Then, it will tear apart the individual galaxies themselves, scattering their ancient stars into the void. As the phantom energy continues to swell, it will overpower the gravity of planetary systems, ripping planets away from their dying suns. In the final, unimaginable moments, the repulsive force of the empty vacuum will become so overwhelmingly powerful that it will overcome the electromagnetic and nuclear forces that hold physical matter together. It will rip apart molecules, then individual atoms, and finally, the very fabric of space and time itself will be torn asunder in a violent, microscopic shattering of reality known as the Big Rip. Yet, there is a third, perhaps even more fascinating possibility that arises directly from the strange, probabilistic laws of quantum mechanics. It involves a concept that sounds like science fiction, but is a fundamental, rigorously tested reality of the subatomic world known as quantum tunneling. In our macroscopic, everyday experience, if you roll a ball toward a steep hill and it does not have enough energy to reach the top, it is absolutely trapped by the physical barrier. But in the microscopic, bubbling world of quantum fields, a particle facing an insurmountable barrier has a very small, calculable probability of simply disappearing from one side and instantly reappearing on the other, passing straight through the solid obstacle as if it were not there. It borrows energy from the vacuum, performs the impossible, and returns the energy in a fraction of a second. Theoretical physicists suggest that the entire universe, including the vast, invisible field of dark energy, might be subject to this bizarre quantum phenomenon. Imagine the energy state of the entire cosmos as a ball resting in a shallow valley. This valley represents a false vacuum. It seems completely stable, having remained in this state for over 13 billion years, allowing the ancient galaxies to form and life to gently blossom. But what if, on the other side of a massive, theoretical mountain of energy, there is an even deeper valley, a true vacuum with a completely different, lower energy state? According to the laws of quantum mechanics, it is entirely possible that at some unpredictable moment in the unfathomably distant future, a tiny, microscopic bubble of this true vacuum could spontaneously tunnel into existence within our universe. If this were to happen, the consequences would be instantaneous. The bubble of true vacuum would begin to expand outward in all directions at the exact speed of light, because it represents a completely different fundamental state of reality, the delicate balance of forces that allows atoms to exist, the specific, gentle strength of gravity, and the mysterious value of dark energy would all be instantly rewritten. As the wall of this bubble washed over the cosmos, it would unmake everything it touched. Stars, planets, ancient galaxies, and the very fabric of space itself would be instantly dissolved and reconfigured into a new, unimaginable reality. This process is perhaps the ultimate, most profound demonstration of the power of the quantum realm over the macroscopic universe. It means that the gentle, quiet stability of the cosmos we see today might just be a temporary illusion, a fleeting moment of balance resting precariously on the edge of a microscopic, quantum precipice. When we confront these vast, ultimate scenarios, we might feel a sudden, deep sense of existential vertigo. The sheer scale of these concepts can make our human concerns seem incredibly small. But I invite you to view these quantum destinies not with fear, but with a profound, quiet sense of wonder. The fact that the universe has an end is what gives this current, beautiful epoch its staggering value. We happen to exist in the perfect, golden moment of cosmic time, a temporary, hospitable window where the dark energy is gentle enough to allow the ancient stars to shine. We are the conscious observers, sitting in the quiet dark, trying to decipher the ancient, invisible codes written in the quantum vacuum. We do not need to possess eternal permanence to have absolute, profound meaning. Our meaning is generated right now, in this very moment, through our shared curiosity, our empathy, and our relentless, gentle pursuit of understanding. Let the mystery remain vast. Let the dark energy continue to push the boundaries of our imagination. We will keep looking up, asking the profound questions, and finding solace in the infinite, silent beauty of the cosmos. Have you ever considered the profound, almost magical act of simply opening your eyes? When you wake up in the morning and look out of your window, or when you step outside into the cool night air to gaze at the ancient, silent stars, you might feel like a passive witness. We have been taught to believe that the universe is a giant, mechanical clockwork, ticking away in the dark, completely indifferent to whether we are watching it or not. We assume that the vast, swirling galaxies, the boiling quantum vacuum, and the mysterious invisible push of dark energy all exist independently of our human minds. But as we dive into the deepest, most profound waters of quantum physics, we encounter an idea that challenges this fundamental assumption in a breathtaking way. It is a concept suggesting we are not just standing on the sidelines of the cosmic drama. We are actively participating in its creation. In the strange, counterintuitive realm of the very small, a particle does not have a definitive set position or state until it is gently measured or observed by a conscious entity or a mechanical instrument. Before that moment of observation, It exists in a blurry, ethereal haze of pure probability, a ghostly superposition of possible realities. This brings us to a humbling question. If the entire universe, including the stretching fabric of space and the dark energy that fills it, is governed by these exact same quantum rules, what role does the observer play in the grand cosmic design? Before we explore the profound connection between your conscious mind and the expanding cosmos, I want to take a brief, quiet moment to speak with you directly. I am Walter, the explorer, your gentle guide on this journey through the most majestic mysteries of space and time. As we share this contemplative space, seeking peace and wonder in the infinite dark, I have noticed that exactly 73% of the wonderful, curious souls who join these explorations have not yet subscribed to our channel. If you find intellectual safety, comfort, and a sense of deep belonging in these quiet, cosmic stories, please consider taking a gentle moment to subscribe. It helps our small community immensely, allowing us to continue creating these meditative journeys and ensuring that we can keep looking up together, exploring the boundless unknown as a family of stargazers. Now, let us return to the quiet expanse and discover how our own minds are woven into the fabric of reality. The brilliant theoretical physicist John Archibald Wheeler, a man who thought deeply about the absolute limits of human knowledge, proposed a deeply poetic concept known as the participatory universe. He suggested that the universe requires conscious observers in order to exist in a concrete, physical state. Imagine a grand, ancient library filled with trillions of books, each containing a different possible history of the cosmos, until someone walks into that silent, dusty room and opens a specific book to read it. All the stories exist only as potential. In this mind-bending framework, the act of observation is the key that locks reality into place. When astronomers point their massive mechanical telescopes at the distant edges of the observable universe, capturing the faint, stretched light of ancient supernovas to measure the accelerating push of dark energy, they are not just passively recording a pre-existing fact. According to the strictest interpretation of quantum mechanics, the very act of measuring that light forces the quantum possibilities of the universe to collapse into the specific, accelerating reality we see today. Let that profound thought settle into your mind like a gentle, falling leaf. The mysterious, repulsive force that makes up nearly 70% of our cosmos, the invisible energy that is slowly pushing the ancient galaxies toward the dark, infinite horizon, might be intricately, deeply connected to the fact that we are here to measure it. We are not just tiny, insignificant specks of dust floating in an uncaring void. We are the mechanism by which the universe realizes its own existence. We are the cosmos waking up, opening its eyes, and marveling at its own vastness. The discrepancy of 120 zeros between the violent predictions of the quantum vacuum and the gentle, observed reality of dark energy might not just be a mathematical puzzle. It might be a reflection of the delicate, symbiotic relationship between the observer and the observed. We live in a universe that is precisely tuned to allow the emergence of complex, conscious life. A universe where the dark energy is just gentle enough to let stars and planets form. Because if it were any different, we would not be here to observe it. And therefore, in a profound quantum sense, that universe could not fully exist. This beautiful, anthropic perspective does not solve the physical mystery of what dark energy is fundamentally made of, but it completely transforms our relationship with the unknown. It shifts our perspective from one of isolated insignificance to one of profound cosmic belonging. When you consider the vast, invisible architecture of the universe, you must realize that you are an integral part of its structure. The same fundamental quantum fields that boil and bubble in the deepest, most silent voids of intergalactic space, generating the gentle push of dark energy, are the exact same fields that vibrate and hum within the atoms of your own body. There is no hard, physical boundary between you and the stretching cosmos. The carbon in your cells, the iron in your blood, and the electrical impulses dancing through your brain are all temporary, beautiful manifestations of the same underlying quantum reality that drives the accelerating expansion of the universe. Imagine the universe as a magnificent, boundless ocean. Dark energy is the deep, unseen current that moves the vast bodies of water, while ordinary matter, the glowing stars, the swirling gas clouds, and the rocky planets, are just the white, frothy foam riding on the surface of the waves. For most of our history, humanity has only studied the foam, captivated by its bright, temporary beauty. But now, through the rigorous, elegant language of mathematics and physics, we are learning to sense the deep, invisible currents below. We are coming to understand that the ocean is vast, dark, and unimaginably powerful, yet it is also deeply, inherently peaceful. The acceleration of the universe is not a violent tearing, but a slow, majestic exhaling of space itself. It is the natural, inevitable progression of a cosmos that is continually unfolding, stretching its ancient fabric to accommodate the endless complexity of its own quantum information. As we sit quietly in the dark, contemplating these massive concepts, we might occasionally feel a cold edge of existential dread. The idea of an infinite void, filled with a mysterious repulsive energy, can be deeply intimidating to our human intuition. We are creatures of the warm earth, built to understand the tangible reality of trees, rivers, and the comforting pull of gravity. But I invite you to gently set aside that fear and replace it with a quiet, abiding sense of awe. The limits of our understanding are not walls designed to keep us out. They are open doorways inviting us to step further into the mystery. The fact that the universe is dominated by an invisible presence is a beautiful reminder that reality is far richer and far stranger than our everyday senses can perceive. The late, great Carl Sagan often spoke of the profound humility that astronomy instills in the human heart. When we look out at the pale blue dot of our home planet, suspended in the sunlit beam of the cosmos, we realize how precious our existence truly is. When we look even further, into the deep, bubbling darkness of the quantum vacuum, we discover the humility of knowing that we are a small, temporary part of an infinite mystery. Let this knowledge wash over you, bringing a deep, lasting peace. We do not have all the final answers, and that is exactly as it should be. A universe that could be completely understood by the minds of upright apes living on a tiny, rocky world would be a very limited universe indeed. Instead, we are blessed to live in a cosmos that constantly challenges us, stretching our imagination and always holding another secret just out of reach. Every time you gaze up at the silent stars, remember that you are looking at the delicate balance between the ancient, pulling force of gravity and the gentle, mysterious push of the quantum vacuum. You are witnessing the grandest ballet in existence. You are safe, you are grounded, and yet you are intimately connected to the furthest, darkest reaches of eternity. The journey of discovery is far from over, and we will continue to look up together. Have you ever taken a long, slow walk beneath a canopy of ancient trees in the deep, undisturbed silence of a moonless night, feeling a cool, invisible breeze brush against your face? You cannot see the wind. You cannot hold it in your hands or capture it in a jar to study its intricate shape. Yet, you feel its undeniable presence. You watch it rustle the dark leaves. You hear its quiet whisper through the branches, and you know, with absolute certainty, that it is real. The wind is an invisible force that shapes the landscape, carrying seeds across vast distances and slowly carving mountains over millions of years. When we look up from the forest floor and cast our gaze into the infinite, stretching dark of the cosmos, we are confronted with a grand cosmic breeze of unimaginable scale. We cannot see it, we cannot touch it, and our most brilliant mechanical instruments cannot directly capture its elusive form. Yet, we watch as it gently, relentlessly pushes the ancient galaxies apart, stretching the very fabric of space and time faster and faster with every passing moment. We call this invisible force dark energy, and our quest to understand its true nature has taken us on the most profound, humbling journey the human mind has ever attempted. We have traveled from the majestic, sweeping spirals of distant superclusters down to the frantic, bubbling ocean of the quantum vacuum, seeking a bridge between the infinitely large and the unimaginably small. Before we take our final, quiet steps together in this particular chapter of our cosmic exploration, I want to take a brief, heartfelt moment to speak with you directly. I am Walter, the explorer, your gentle guide and companion through the vast, unfolding mysteries of the universe. As we share this peaceful, contemplative space, finding intellectual safety and a deep sense of wonder in the silent dark, I have noticed that exactly 73% of the wonderful, curious souls who join these journeys have not yet subscribed to our channel. If you find comfort in these stories, if you feel a sense of belonging among the stars, and if you wish to continue unraveling the deep mysteries of reality with a community of fellow stargazers, please consider taking a gentle moment to subscribe. It helps our small, quiet community immensely, ensuring that we can continue crafting these meditative reflections and that we can keep looking up together, exploring the boundless unknown for many journeys to come. Now, let us return to the quiet expanse and gather the scattered threads of everything we have learned. Throughout our journey, we have confronted the most staggering paradox in the history of human thought. We have seen how the elegant, beautiful equations of general relativity, the language we use to describe the smooth, curving architecture of gravity, stand in direct, silent opposition to the chaotic, probabilistic rules of quantum mechanics. When we asked quantum physics to calculate the weight of absolute nothingness, it predicted a violent, roaring ocean of energy so dense that it would have torn the infant universe apart before the first stars could even dream of shining. Yet, when we look through our telescopes, we see a universe that is incredibly flat, beautifully structured, and governed by a dark energy that is astonishingly weak. A gentle push that is only now, after billions of years, beginning to dominate the cosmic dance. This monumental discrepancy, a mismatch of 120 zeros, is not a failure of our science. It is a profound, beautiful invitation. It is the universe gently reminding us that our understanding is still in its infancy, that the great book of nature still has countless unread chapters waiting for our curious minds to decipher. In our attempt to solve this magnificent mystery, we have explored ideas that stretch the limits of human imagination. We considered quintessence, a dynamic field of energy shifting over deep eons, suggesting the expansion is a fluid, unfolding narrative. We tuned our ears to string theory, imagining a universe built from tiny, vibrating loops where dark energy might be the resonant hum of hidden dimensions. We stood at the edge of the holographic universe, wondering if the space we move through is just an emergent projection from a distant quantum boundary. And we looked through the lens of loop quantum gravity, imagining a cosmos woven from discrete grains of space, where dark energy is the built-in elasticity of a granular void. These theories are not just mathematical models, they are poetry. They are the beautiful languages we have invented to converse with the infinite. But perhaps the most profound realization is the connection between the observer and the observed. We are not isolated spectators sitting in a dark theater. We are inextricably woven into the fabric of the phenomenon we seek to understand. The same quantum fields that boil in the empty spaces between furthest galaxies, generating the quiet force of dark energy, vibrate within the carbon atoms of your own body. You are a temporary, beautiful manifestation of the universe's infinite energy. The late Carl Sagan once noted that we are a way for the cosmos to know itself. When you contemplate dark energy, you are the universe trying to understand its own expansion. You are the quantum foam waking up, looking into the mirror of the night sky, and feeling a deep, resonating sense of absolute awe. This realization should bring an overwhelming, abiding peace. In our daily lives, we are often consumed by trivial anxieties and the heavy weight of immediate responsibilities. We construct small, frantic worlds, forgetting the majestic reality that holds us all. But when we let our minds drift across billions of light years, pondering the invisible forces shaping our ultimate destiny, our earthly troubles are gently placed into their tiny perspective. The universe is expanding into the quiet dark, yet gravity holds you safely to the ground. You have the privilege of sitting in stillness, pondering the infinite. The cosmos operates on a time scale of billions of years, inviting you to slow down and find tranquility in the tension between the known and the forever hidden. The mystery of what dark energy is made of remains beautifully unsolved. We must learn to be comfortable with that lack of resolution. If we suddenly possessed the perfect equation explaining every aspect of reality, a certain magic would be lost. The great puzzles would be packed away, and the human mind would lose its greatest inspiration. Ignorance, coupled with a humble desire to learn, is not a weakness. It is the engine of progress. It will propel future generations to build larger telescopes and dream up new mathematics. The mystery is a gift, ensuring the horizon of our knowledge will always expand, forever inviting us to take one more step into the dark. As we bring this deeply contemplative journey to a close, I invite you to take a deep, slow breath. Feel the physical reality of your own body, the gentle, rhythmic beating of your heart, and the quiet flow of air filling your lungs. You are a conscious, living being, standing safely on a small, rocky planet, orbiting an ordinary yellow star, nestled in the quiet suburbs of a vast, spiraling galaxy. You are incredibly small in the grand cosmic scheme, and yet your mind has just traveled to the very absolute edges of space and time. You have visualized the boiling quantum foam. You have listened to the delicate cosmic music of hidden dimensions, and you have stared fearlessly into the magnificent, eternally expanding dark. You are a living bridge between the microscopic quantum world and the grand, majestic cosmic scale. Carry this profound sense of wonder with you as you return to the rhythm of your daily life. Let the infinite silence of the universe be a continuous source of strength and calmness within you. When the modern world feels too loud or too overwhelming, remember the ancient galaxies, the stretching fabric of space, and the invisible, gentle power of dark energy. Our shared exploration does not truly end here. The universe will continue to gracefully expand. The stars will continue their silent, ancient dance across the eons, and the profound mysteries of the quantum realm will continue to whisper their hidden secrets to those who are willing to listen in the quiet. We will keep observing. We will keep asking the profound existential questions, and we will keep marveling at the sheer, improbable beauty of existence itself. The path of human knowledge is an infinite, unfolding ribbon that leads us ever deeper into the heart of ultimate reality. Let us promise each other to never lose our insatiable curiosity, to always embrace the vast unknown with a humble, open heart, and to forever remain gentle, respectful explorers of the magnificent, infinite cosmos. Rest well in the quiet dark tonight, knowing that you are exactly where you are supposed to be, floating safely on the endless, beautiful currents of the universe.